All right, picking up with the law of sines where we left off. The first thing we're going to do is figure out how many triangles we have. How many triangles we have. Because if we have 0, there's no work to do. If we have 1, there's only one triangle to solve. But if we have 2, we have to do double the work. Yay! Okay? So we're still just doing that. We're not solving right now. First of all, if you look at this, how do you know that this is going to be the law of sines? Right, it's side-side angle. You got two sides at an angle, and you know it's not side angle side. You know it's not the included angle because you have a repeated letter. If you have a repeated letter, it's going to be angle side side, the pain in the butt case. So to determine how many triangles, we draw a base, and then you go to your given angle, and you try to draw it somewhat to scale, 45 degrees. There you go, 45 degrees. And then the other arm is your swing arm. It can swing back and forth. Then we go ahead and label the base angle is 45 degrees. That's B. So the swing arm must be B, which is 6. And then the other side, you can call whatever letter it is. In this case, it's A. And now the question is, how many solutions, right? Well, 6 is shorter than 7. And because 6 is shorter than 7, we don't know if it touches the other side, do we? It might be just long enough or it might be too short. We have to calculate something else. We got to calculate the altitude, right? We got to calculate the height. So to do that, we'll just do the sine over here. We get sine of 45 degrees equals the opposite, which is h, over the adjacent hypotenuse, which is 7. And then we solve for h, and we get h equals 7 sine of 45. And you can go straight to that step if you want, because it's always going to be that side times sine of the given angle. And now we go to the calculator, and we just type it in. We're in degree mode, right? We're in degree mode. If someone reset the calculator, you're going to have to check what degree mode is. So the height is 4.949. So is 6 long enough to reach the side? It is long enough to reach the side. So I know I'm going to have at least one solution. So I can go ahead and finish drawing that right there. So I have that solution. But if I swing that thing around, is it going to intersect inside or outside the triangle? It's going to intersect inside the triangle. And we know that because 6 is less than 7. So for the acute case, if 6 is less than 7, you know there's going to be 2 solutions. All right? So that's what we'll say here. 2 solutions or 2 triangles, whatever you want to say. All right, questions on D? Letter E. 2 sides, 1 angle, repeated letter. That's going to be the ambiguous case. That's the angle side side case. So again, we draw our base. And now we have an angle of 170. That's not acute, is it? So you want to kind of draw it to scale. 170 is going to be really, really close to 180. It's going to be way over there. Label that as 170. And label that as C. And then you have your swing arm, which is this one here. And that's going to be little c. And then you have the other side is B. It's 39. All right, so if we label C, it's going to be 52. And now we analyze, right? Is 52 long enough to reach the side? It is, because it's bigger than 39. So I know it's going to intersect at least once, maybe somewhere out there, if you extend it. But if you swing that thing around, since 52 is bigger than 39, it's going to intersect outside the triangle. And so that's not a triangle for us. Maybe a triangle for someone else, but not for us. So how many solutions do we have? Just one solution. Yeah, good. Letter F. We got some decimals, but we have, again, side-side angle, and we have a repeated letter, so it's the ASS case. So we draw our base, pain in the butt case. 55 is going to be a little closer to 60 up here. We'll call that 55. I'm not going to be so picky about putting degree symbols on all of your degrees for your intermediate calculations. But if we're reporting an angle, you'll see if we're reporting an angle as an answer, you need to have the degrees on it. All right, so let's go ahead and label it now. 58 is A, so the opposite side is A, which is 3.8. Oh, yeah. It's supposed to be 55. I can't even read my own writing. It looked like an 8, and I read it as an 8. Thank you. 55, 3.8. And the other side is C, which is 4.6. So what do you think? Is 3.8 long enough to reach? Barely? Did you already calculate it? It's hard just to look at it and say, yeah, because it could be that it could be that it's just a little too short. It could be that 3.8 lands right there. We'll have to calculate the altitude again, won't we? Let's calculate the altitude. So H is going to be 4.6 times sine of 55 degrees. The adjacent side times sine of the angle. Okay, or you can set it up and solve for it. And now I type it in 4.6 times sine of 55. And I get H is 3.768. So you're right. How many solutions? 2. Yeah. The swing arm looks more like this, though. It looks more like this for that. And then you swing it across, and you get this other one right here. So yeah, there's 2 solutions. Yes?
I don't understand the swing arm.
You don't understand the swing arm? Okay, let's say you have let's say you have dirt. Does that look like dirt to you?
Yeah.
Okay, dirt. And let's say you have an excavator right here.
A what? An escalator?
No, an excavator. Yeah. Not a wrecking ball. Something with a shovel. Okay. And let's say that it's digging. Let's say it's digging. So let's say it's digging right here. Right? And there's a shovel on it, right? There's the shovel. I'm not a good artist. But it's going to dig the dirt out, right? And as it goes, it's going to dig all this dirt out. And the shovel is going to reappear right here, up from the dirt. Does that make sense? That you're scooping out dirt? Look, we scooped all this out.
How do you know where it's going to end?
What's that?
How do you know it's going to end?
How do you know it's going to end?
Where?
Oh, well, you have to. Right now, we're just determining if it lands inside or outside, and you know it's going to land inside if this is like 5, and this is 4. As long as the swing arm is smaller than 5, you're going to have 2 solutions if it's long enough to reach. But if this angle is fixed right here. But what if I lift that boom arm up? Oops. What if I lift the boom arm up and now it's up here? Where'd my orange go? There we go. What if it's now up here and you have the swing arm coming down here? Oh crap. Swing arm comes down here and now it's trying to scoop, right? And it can't scoop any dirt, right? Because it doesn't touch the ground. So that would be 0 solutions. The other one that I just showed you where it scooped out dirt would be 2 solutions. Now, what if it lowered it just to the point? What if it lowered it just to the point where it came down? We'll reestablish this as dirt. What if it came down and it was just long enough to reach and the shovel rested on the ground? Then there'd be 1 solution. Okay? Does that help with my excavator analogy?
Yeah.
Okay, good. Digging dirt. That's all we're doing. We're digging dirt. That's a pretty cool excavator. Oh, it's got to say something on it. It's got to say like cat. Yeah, very good. Cat. Yeah. Okay. Example 5. Not like meow cat, but like caterpillar cat. This is my caterpillar. Thank you. Solve. Look, solve triangle ABC if big A is 43.1, little a is that, and little b is this. So is this the ambiguous case? It is, right? Good. Two sides and one angle, and there's a repeated letter. So it is the ambiguous case. So step one, draw the triangle. Now we're gonna need a lot of room here, so draw your triangle kind of small. It's gonna be there. Oops, I messed it up. There it is. And our angle is 43.1. So draw it kind of to scale, if you will, a little bit. There's 43.1. So this is angle A, 43.1. I'm not going to put the degrees just because, well, I will put the degrees, the degribbles. Hello. Oh, Landon Marsh. Okay. If I can get out of this desk, I'll give it to him. I can get out. I'm just kidding. There you go. Tiny desk, big teacher. All right. And so the swing arm, or the shovel arm, if you will, is 186.2, and that's little a. And then the other side that's given, little b, is 248.6. There you go. So now the first question is, like we've been doing, how many triangles are there? 186 is less than 248, right? So I don't know if there's one solution or possibly two, okay? Or zero, right? I still don't know. I got to calculate the altitude, which is h, and h is equal to 248.6 times sine of 43.1. And so if we compute that, 248.6 sine of 43.1, the height, very good. The height is 169.861. So you need to be at least that long to touch the other side. All right, and it is, right? 186 is at least that long. Now, because it's at least that long and also smaller than 248.6, we're going to have two solutions. All right, so there are two solutions. All right, so what I'll do here is I'll finish my diagram like that, and I'll solve this triangle first, and then I'll come and do the other one. Let's solve this triangle first. So finishing out the lettering here, this is angle B, this must be angle C, and this must be side length C. Now, before when we used the law of sines to solve triangles, we were finding side lengths first. Can we find a side length, little c or little, can we find little c? We can? Let's try it out. To find little c, we're going to put the side length in the top. We're going to have little c all over sine of angle C. Rut-row. We can't do that, can we? It wouldn't equal c squared. It would equal h squared. It's not a right triangle. Can't use the Pythagorean theorem here. We can't find c, can we? Because we're missing the angle opposite it. So can't do this yet. So I guess we have to find an angle. No, because we don't know if those two angles are the same. Yeah. Yeah, we don't know any of the other two. We don't know the other two angles yet. But let's go ahead and focus on the base angle down here, B. Okay? We can actually find that, I believe. We have our pivot guy. Here's our pivot guy. So let's go ahead and set it up. We got little b, which is 248.6, all over the sine of angle B. Oh, you know what? Because we're finding the angles, let's go ahead and put the angle in the top. Let's flip the ratio. Let's do sine of B over little b, 248.6. That'll save us a little bit algebraically. And that's going to equal our pivot guy, which is sine of 43.1 all over 186.2. Now to solve for sine of b, first we have to multiply both sides. So we get 248.6 sine of 43.1. It's going to be a little bit of writing. You can just sit on my desk if you're done.
The girl that works like the American,
Yeah?
she helped me yesterday with the rest of it.
Oh, okay.
Yeah.
Just put my mouse on top of it because it might blow away. There you go. Thank you. All over 186.2. Miss Skirhawk, that's her name.
Yeah.
Yeah, yeah.
Help me with the test.
Okay, now we have to solve for B. And to do that, we have to take the inverse sine of both sides. Yikes. So here we go. B is equal to the inverse sine of all of this mess right here, which I'm just going to copy and paste because notability, yum. Notability is pretty nifty. I got to admit that. Now that's an exact answer, but now we're going to type it in. So second sine, the inverse sine, second sine of alpha y equals enter. Get your horizontal division bar there. 248.6 times sine of 43.1, all divided by 186.2. And here we go. We get angle B is 65.818 degrees. Since that's the final answer, I'll expect to see the degrubble around it. And now, here's what I'm going to do. I may need to use that again. So while it's on your screen, hit stow as alpha B, because that's the name of the angle. Stored as alpha B. And now it's in there forever. Stow is right above, well, it's right below natural log. Now that I have angle B, and I also have, let me write it in here. It's 65 dot dot dot. I don't have room for it. Let's put 65 dot dot dot. Now I can find the third angle, right? So let's find the third angle. You don't have to show me the calculations, just do it. It's going to be 180 minus alpha B, what I just found, minus the 43.1. Because the sum of all the angles is 180. Hit enter, and you get C is 71.081. All right. Now, are we done with this triangle? No, I need to find little c. So I can finally find little c. So we're going to put the side lengths at the top now. So we get little c. Oh, let me store this as c. Store as alpha c. Store your angles. You might need to use them again. We'll store that as alpha c. And it's called c on your paper. Now we'll do little c over sine of big C. And if you want to put big C there instead of 71.081 dot dot dot, that's fine. That's a reminder to yourself to use the stored value. And then it equals the pivot guy. The pivot guy is still going to be 186.2 all over sine of 43.1. All right, so now let's solve for C. Little c is going to equal sine, or 186 I should say first, 186.2 sine of my stored value of C all over sine of 43.1. And now we'll just type it in. Alpha y equals, boom, 186.2 times sine of alpha C all over sine of 43.1. Hit enter, and there it is. Little c is 257.790. Do we need that third zero in our report? Yes, because it's not a terminating zero, right? It's just another value in the accuracy. So yeah, we need the zero there. And we'll put this in a box as well. It didn't box it so pretty. There we go. Thanks, Notability. And that's it. We solved that triangle, didn't we? Yeah. Okay. Now let's envision what the other triangle is going to be. The other triangle is going to have the same base. It's going to have the same boom arm, but it's going to be, oops. It's going to be coming down like this to the base. So what's going to be the same? 43.1 degrees. This is going to be the same. That's A. B equals 248 0.6. That's going to be the same. And A is going to equal 186.2, which is A. It's still the same. So let's label what we still need. We still need B, we still need C, and we still need little c. So we got to find those three all over again. Yeah. Little c and big C are going to be smaller, but big B should be bigger, right? Our first triangle was acute. The base angle was acute. And what do we know about our base angle now? It's obtuse. Okay, cool. All right. First things first. Let's find B. So we'll put the angles in the top again. So sine of B over 248.6 equals our pivot guy, which is sine of 43.1 all over 186.2. Now with a little bit of practice, you can go straight to solving for B. We're going to have to multiply both sides by 248. So leave a little space. 248.6 times sine of 43.1 all over 186.2. And now take the inverse sine of both sides, which you could just put right in front. So it saves the line of writing. All right, now if we type it in, we get second sine alpha y equals 248.6 sine of 43.1. Oh, I just deleted it. I'm an idiot. Second sine alpha y equals. Hopefully you got, 65.818 if you truncate, which I'm a big fan of truncating. Is not worth the answer? Did I type it in wrong? Oh, yeah, you're right. Hey, I'm having a little deja vu myself. We got the same B value over here. That's not good. That's not good. So if you remember up here when I said using the law of sines, you can use the law of sines to find side lengths with reckless abandon, right? With reckless abandon. You're always going to get the right answer. But if you're finding angles using the law of sine, you have to do it how? Carefully. And we have to be careful down here because we don't get the answer we want. So what can we do? Well, what do we know about those two angles? Let's just draw that off to the side. Here's one angle, here's the altitude. Here's the other angle, that's the same altitude. This angle is going to equal this angle. This side is going to equal that side. It's going to be an isosceles right triangle. So, what's that? We're going to subtract it from 180. That's it. We're going to subtract the given angle from 180. So that's not our B value. That's B sub 1, I guess we can call it. So our B value is actually 180 minus B, which I still have stored as alpha B. 114.181 degrees. That's a little bit better. Okay, so you have to know in advance if you're looking for an acute or an obtuse, because remember the inverse sine will never, ever, ever, ever give you an obtuse angle, never. So you have to do the work yourself if it's obtuse, and it's as easy as finding the supplement of the given angle. Okay, now that we have B, we can find C. Let me store this as my new alpha B. My new alpha B. So I just overrode the other one, which is fine. And now my new alpha C is going to be 180 minus 43.1 minus alpha B, which is 22.718 degrees. And I'll store that, if I need it, as alpha C. And I'll box that up as well. Every time I say box it up, I think of donuts. Or put it in a box, I think of donuts. I can't help but think of donuts. I tell myself, you're about to say, put a box around it. Try not to think of donuts. And then I say out loud, put a box around it, and guess what flashes into my brain? Donuts. Yeah. Did you? Where do you get yours from?
The girl got it from Shipley's.
Shipley's. That's where I usually go. Yeah. All right. Now we need to find little c. Little c. So we're gonna use it like this. We're gonna put the side lengths in the top now, not the angles. So we're gonna get little c all over sine of our new c, which I'm gonna put the letter c in there as a placeholder, and you can do that too as an intermediate calculation. And then I'm gonna use my swing guy. My swing guy is going to be still a, so is 186.2 all over sine of 43.1. And if I solve for c, and by the way, the notation that I'm showing here on a test or quiz, I'm going to expect to see it. So don't do too much in your head. I'll expect to see that right there. And now we'll go to the calculator. Alpha y equals 186.2 sine of my new alpha c that I stored all over sine of 43.1. And we get c is 105.246 when we truncate. And there's no units on that, so you don't need them. There it is. All right, so the ambiguous case when you have two solutions, it's a pretty good bargain, isn't it? It's a 2 for 1, a 2 for 1. And in today's economy, when inflation is so high, 2 for 1 is a good deal. Back in the day, places used to offer like what they call BOGO sales. Have you heard of a BOGO sale? Yeah, BOGO is buy one, get one. But back in the day, it was buy one, get one free. Everyone's doing buy one, get one free. And then they're like, oh, we're giving away too much free stuff. So then it became like buy one, get one half off, which is not as good of a deal. And I bet now it's like buy one, get a coupon for $2 off your next purchase. You know? Okay, thank you. But this is 2 for 1. It's a good value. All right. Last one. You ready? Anyone want to climb a mountain? Good. We don't have to climb a mountain because we could figure out how tall it is from the ground. How about that? And this is how they measure mountains, like Mount Everest and Mount Washington and Lhotse and what is another mountain? Mount McKinley. What? The what mountains? The Ural? Oh yeah, you can measure any one of the Ural mountains. The Karakoram range, you can do that too. Mount Fiji, yeah. Mount Kilimanjaro, Denali. What? Even Enchanted Rock, you can figure out how high it is without going to the top. Let me show you how.
The world's biggest rubber band ball?
Yes. To measure the height of a mountain, a surveyor takes two sightings at the peak of the peak at a distance of 3,000 feet apart at the same elevation. The first observation results in an angle of elevation of 48, and the second is at 35. If the transit, the tripod that he uses to measure the angles, is 5 feet tall, what's the height of the mountain? Okay, first step is to draw a mountain. Oops, I want to use blue. There's always an awesome snow cap on it, right? All right, now we're going to assume that the guy measuring it is on the same elevation as the mountain. Okay. So he has this little tripod right here. And he takes a reading to the top. Boom. And he calculates the height. Now, if we draw let's draw a dotted line. I'm going to draw a dotted line. If we drew a dotted line straight through here for his tripod, it's not drawn to scale, obviously, but this distance right here is 5 feet. All right. He takes another sighting now from 3,000 feet closer. Well, I'll just say it's closer. So he sets up right here. He takes another reading to the top. Now, from those two readings and knowing that this is 3,000 right here, which he can measure pretty easily on the ground, you can't measure the mountain by using a tape measure. I've tried it. Trust me, it doesn't work. He can approximate the height. So let's label what else we know. This angle here is 48 degrees. and this shallower angle is 35 degrees. We call those angles of elevation. They rise from a horizontal, angles of elevation. All right, let's go ahead and give these points names. Let's call this point A. We'll call this point E at the top for Everest. We'll call this point B, and let's call this point, let's do this. Let's drop a perpendicular straight down, and we'll call that H. So we're working with two triangles, but they're all above 5 feet tall, okay? So disregard the 5 feet for now. We're just looking at these two triangles. All right, we need a plan of action here. How are we going to determine the height? If this is ultimately what I want to know H, and then all I have to do is add 5 to it at the end to get the height. That's a right triangle. But for a right triangle, I need two pieces of information, don't I? Yeah, and I don't have two pieces of information. I have an angle for each one. There's two right triangles, the big one and the small one. But let's go ahead and finish off some of the angles. If this is 48, the angle opposite here has to be what? Yeah, which is 135. 135. And now this shallow angle up here, if you're interested, should be 180 minus 35 minus 135. Oh, 132. Yeah, sorry. Yeah, so this would be 132. I don't know why I wrote 5. $12? Yeah, it's 13. Yeah. And that's about all the angles we can fill out there. So now we can set out to try and find it. If I knew, I only need one more piece of information for the two right triangles. So if I knew the hypotenuse here, I can use right triangle trigonometry to find the height. Same thing on the inside. If I knew this height here or this hypotenuse here, I can use right triangle trigonometry. But I need the law of sines to find that missing side. So I think the side that's in common would be this one. I think that might be the one to find, don't you think? Let's go ahead and find that. So what side is that going to be? That's going to be little a. Yeah, we're going to call that little a. And then I might as well label these little b. And then, all right, let's go ahead and set it up. We want a side length, so we'll do a all over sine of 135. We'll do 35. We're doing that obtuse triangle equals 3,000 all over sine of 13. We're working with this guy right here. Oops, they're not showing up too well. Oh, that's all we need. Okay, let's go ahead and find A. A is going to be 3,000. Bless you. All over sine of 13. So we get alpha y equals, boom, 3,000 divided by, or sorry, times sine of 35 divided by sine of 13. We get A equals 7649.349. I'm going to store that as alpha A because I'm going to need to use that again. 7649, dot, dot, dot. Now, since I found that hypotenuse, I'm going to go ahead and use the smaller triangle. So I'm going to use this guy in red now to find H. And I don't need to use the law of sines anymore. I used it once to find the value that I need. Now I can use right triangle trigonometry. So if I have 48 as my base angle, I want to find the opposite side, and I know the hypotenuse. So which trig function is that? Opposite and hypotenuse. So again, so that's sine. So sine of 48 degrees equals the opposite over the hypotenuse, 7649. .349 ... That's a reminder also to use the live answer. And so H is equal to, I'm just going to call it A sine of 48 degrees. And now we get alpha A times sine of 48. And we get 5684.574. So the height, so the A, I'll call it big H. Big H is this right here, top to bottom. So big H is equal to little h plus 5, which is equal to just, I say plus 5. It's 5689.574 feet. Not bad for a mountain. Not bad at all. All right. And that concludes the notes. So we have a little bit of time left in class if you want to work on it. Otherwise, it's just going to be due on Monday. Any questions? A little mountain climbing today, or mountain. We didn't have to climb it. All right. Bye, everybody.